Hi guys, welcome back to Enginerds YouTube channel. My name is Patricia Bermudez and I'll be your host for today's video. And for today's video, we will be discussing the Trouton-Hildebrand-Everett rule, or THE rule for short. So this rule is actually used for finding the enthalpy of vaporization or the entropy of vaporization. And we will use that to substitute for the Clausius-Clapeyron equation. So the problem states that the normal boiling point of bromine is 58.8 degrees Celsius. Calculate its vapor pressure at 25 degrees Celsius in bar. Assume THE rule applies in this problem. So if you notice here, unlike problems in Clausius-Clapeyron equations, na dun lang mismo nakafocus, dito, ang given lang natin here is normal boiling point. So we have the normal boiling point, which is 58.8 degrees Celsius. And we know that when we're talking about the normal boiling point, it is the boiling point at sea level. And we know that at sea level, our pressure is equals to 1 atmosphere. But since the question is asking for the pressure in bar, we have to convert this pressure into bar as well para consistent yung units natin. Okay? And then we know here that 1 atmosphere is equals to 101,325 Pascal. Okay? And we know that 10 raised to 5 Pascal is equivalent to 1 bar. And here, makakancel yung units and matitira yung bar. Cancel yung ATM, makakancel yung Pascal. Ang unit natin for pressure at sea level will be in bar. So calculating, what do we get for pressure? We have 1.01325 bar. And this is our pressure at sea level kung saan yung boiling point mo ay normal. Okay? So we can set this as, let's say P1 is equals to 1.01325 bar. And then our T1 is the corresponding boiling point, which is 58.8 degrees Celsius. And converting that into Kelvin, we have to convert it into Kelvin here kasi you can see that it is more convenient later if you substitute it dun sa Clausius-Clapeyron equation natin. So 58.8 plus 273.15, it'll be 331.95 Kelvin. Okay? So meron tayong one set ng value, pressure and temperature. But then the question is asking for the pressure, which is P2, at this temperature, which is 25 degrees Celsius, and that is equal to 298.15 Kelvin. You can see here, wala pa tayong delta H, pero wala din tayong P2. And we know that the Clausius-Clapeyron equation is given by this equation, which is ln P2 over P1 is equivalent to the delta H vap negative over R, and that is multiplied to 1 over T2 minus 1 over T1 here. So, meron tayong value ng P1, T1 and T2. Pero wala tayong T2 at wala pa rin tayong delta H vap. So, paano natin makukuha yon kung insufficient yung given na value sa atin? Dito natin gagamitin yung Trouton-Hildebrand-Everett rule. And this THE rule states that yung R multiplied by 4.5 plus the ln of the boiling point, which is given by TB over Kelvin. Itong unit ng ln dito is per Kelvin, is equivalent to the change in entropy of vaporization. Okay? And we know that the change in entropy of vaporization is equivalent to delta H vap over T. So from this equation, this rule, mahahanap natin yung delta H vap. And therefore, pag sinubstitute natin siya dito sa Clausius-Clapeyron, P2 na lang talaga yung matitira and we can find that using one equation. Okay? Kasi ngayon, dalawa pa yung unknown natin, delta H VAP and P2. And dito napapasok yung THE rule para isa na lang yung matirang unknown natin. Okay? So, ang boiling point natin here is this one. As stated in the problem, is 331.95, right? So, to find the delta S of vaporization, we substitute that into this rule. So, for R, we use 8.314 joules per mole Kelvin. And then 4.5, wala yung unit, plus Ln. Ano yung boiling point natin? 331.95. So, 331.95 Kelvin per Kelvin. Okay? Yan yung equation natin. Ito per Kelvin. Okay. Yan natin yung TB per Kelvin. Okay? So, all that is equivalent to S bar. So, calculating, we will get, ito makakancel, Kelvin makakancel. So, makukuha talaga natin yung delta S back. And so, delta S back is equal to 8.314 times 4.5 plus ln of 331.95. Okay? And that is 85.67563993. And ang unit natin is joules per mole Kelvin. Joules per mole Kelvin. And therefore, in order for us to find delta H, we have to multiply this by T. If we're going to transpose this to the other side, magiging multiplications siya. So, it'll be delta S VAP times T. And ano yung T natin? It is the boiling point temperature also. Okay? So, kasi ito, delta H VAP, ito delta S VAP, and VAP indicates vaporization. Anong temperature ba nag-vaporize yung bromine natin? It is 331.95. So, yun din yung T natin here. So, if we're gonna equate that, it will be 85.6756393 joules per mole Kelvin multiplied by the temperature, which is 331.95 Kelvin. See, makakancel yung Kelvin natin here. Ngayon ang matitirang unit ay joules per mole. So, calculating, we have 28,440.02867 joules per mole. And that is our delta H VAP. And what we're going to do is to substitute it into the Clausius-Clapeyron equation. So, substituting, we have ln of P2 over P1 is equivalent to the negative delta H VAP over R, 1 over T2, is 1 over T1. And we know that ln, ang P2 natin here, going back, is unknown. So, let's leave it as P2. And ang T1 natin is 1.01325 bar. So, 1.01325 bar. Okay? And that is equals to negative, yung delta H VAP natin is 28,440.02867 joules per mole. Joules per mole. Yeah? And then over yung R natin, which is 8.314 joules per mole Kelvin. And then our T2 is corresponding dun sa hinahanapan natin na pressure, and that is 25 degrees Celsius. So, it'll be 298.15 Kelvin minus yung T1 natin, which is the boiling point, and that is 331.95 Kelvin. And you can see here, makakancel yung units natin ulit. Joules, cancel, per mole, makakancel. And yung Kelvin ay makakancel here. Kasi, ito, technically, nasa numerator yan. So, ang unit dito sa, ito technically is 1 over delta T. And that is 1 over K, right? And dahil siya, ito, nasa numerator yan. Nakamultiply yan sa delta H VAP. It'll be 1 over K over yung unit here, which is joules per mole. Kelvin. Makikita mo, makakancel yung Kelvin. Kasi ito, nasa denominator siya. Ito, nasa denominator din. So, makakancel yan. So, now we just have to find our P2. And if we're gonna do it manually, if we want to isolate P2, we have to raise both equations to E. At ito, magiging exponent yan ng E. Itong buong yan. Kasi we know that E, ln of x, is equals to x. So, pag ni-raise natin to sa E, ang magiging equal yan ay P2 over itong P1 natin, which is 1.01325 bar. And that is equals to the E. And then, ito, i-simplify natin tong exponent ng E na yan. So, negative 28440.02867 over 8.314 multiplied by 1 over 298.15 minus 1 over 331.95. Ito yung exponent ng E, which is this one. Yung naka-bracket here, it is equivalent to negative 1.168232337. At dahil na-cancel natin lahat ng units, this is unitless. And this is the exponent of your E. And i-transpose lang natin siya here. It'll be E raised to negative 1.168232337. So to isolate this, ang gagawin lang natin here is transpose it to the other side. Kung divide siya here, magiging multiply siya when transposed to the other side. So P2 is equivalent to 1.01325 bar times E raised to negative 1.1682337. And matitirang unit ay yung bar. So that is our unit for P2. So calculating, we have 0.315 bar. And that is our answer for the problem. So we have found our pressure that is being asked for in the problem. I hope you guys learned a lot from today's video. Thank you for listening and stay tuned for the next one. Bye-bye.